Hey, Matt Mathersum here with Matt Madness. Thank you so much for joining us today and being a part of the program. We're excited to be here. Hope you are too. Well, as you can see behind me, we have a bit of a curve that we were asked to evaluate. Now, this is a definitive integral because we've got a bound here of 1 being the top bound and 2 being our lower bound. This is basically very simple. Well, this is going to be a relatively easy integral to take care of. But I want us to focus on how much algebra is being used and how much elementary mathematics is utilized in solving what looks like it could be potentially intimidating, but I can assure you it's not. Now, you know, when you get with me, we have an equation, or when we have a function to evaluate, you know where I'm going? I'm going with a formula. And the formula to guide us through this is real simple. It's just the integral of x to the n dx, which is equivalent to x raised to the n plus 1 over n plus 1. This, my friends, will guide us to the shores of safety, or whatever analogy you want to use here. All right, we said that we were asked to evaluate this, and this is our guide. So let's just go ahead and start with this. As you can see, we've got an x here, and we've got an x here. If you look at this particular part of it, x is being raised to an n plus 1. Well, over here in our actual problem, our n is represented by 2. Yes, and if we say 2 plus 1, that gives us, yeah, absolutely, it gives us 3. So let's just go ahead and take care of that this manner right here. All right, well, that looks like that took care of the numerator. Now it looks like we've got this pesky denominator, n plus 1. So let's just go ahead and restate this over here as x to the third dx over n plus 1. Well, what is our n plus 1? Well, it was 2 plus 1 over here, so it's going to be 2 plus 1 down here. I'm not going to write that. I'm just going to take that sum, which is 3. All right. Well, this almost looks like a dollar sign. I don't know if I'm trying to speak money into existence here or not, but I definitely want you to understand that this is integration, not dollars. All right. Well, algebra to the rescue, right? You can see that we've got a 3. Here's the coefficient in the numerator, and we've got a 3 in the denominator. What would you do with those? Even if this integration symbol wasn't here, yeah, you'd absolutely just cross those out. Now, what does that leave us with? Well, what that leaves us with is it leaves us with my integration is said and done. But we're not done with the problem yet because we are asked to evaluate this at the bounds of 1 and 2. So let's evaluate this between the bounds of 1 and 2. I'm going to bring this part of the problem solved back over here, and it will look like this. I'm going to draw our vertical line because we have to understand and let this represent that we are still taking the bounds of 1 and 2. We know that we're going to subtract the bottom bound from the top bound. So let's go ahead and plug in our top bound. Again, algebra to the rescue. The top bound into what? To our x variable right here. 1 times 1 times 1, because it's being cubed, gives us 1. It does indeed. All right. Well, we said we are subtracting the bottom from the top, so let's acknowledge that. I plug in my 2 here into the x, and 2 times 2 gives us 4, and 4 times 2 gives us a whopping 8. Okay. Well, that just leaves us with 1 minus 7, doesn't it? And that gives us a negative 7. I mean, look at this really quick. Basically, a little algebra right here, an x being raised to the n plus 1, but you've got a little bit of a division here. Elementary math. That's what we essentially used, a little bit of algebra, more elementary math to solve this integration problem. Well, I hope you enjoyed this as much as I did, and I will see you very soon. I'm Matt Mathersum. Have a wonderful day.